Okay, so as an introduction to this video, apart from the introduction, if you vary the slit width, so if I make the slit width wider, the diffraction pattern gets tighter together. In fact, let's have a look at the intensity profile. So if I make the gap smaller, it gets more spread out. Some things to notice: single slit diffraction, your central maxima is twice as wide as your subsidiary maxima. Yeah, so it's this question: why is it that when you get a wider gap size, you get a narrower diffraction pattern? That this video is intended to answer. So now we're going to go to a sort of physical model rather than this computer model, which comes via walterfent.de. Fantastic set of simulations if you want to have a go with them. They've now got HTML5, so I recommend having a look at this site. But let's move on to the physical demonstration. Okay, welcome to a short video just giving some extra details about single slit diffraction and some of the stuff that's hard to imagine you need to see explained visually. Right, so if we look here, I've made a model, and the idea is that you can imagine a ripple coming in like this, and then it's going to diffract through here, and what we're going to look at is just the wave that comes out at the edge here and the wave at the edge here, and how they will interfere with each other, and that should tell us everything we need to know about what's going to happen. So let's start by looking. These waves travel the same distance to the screen, and if you look, you can see the peaks and peaks and the troughs are all matching up, so you get a nice bright spot here. If we think, well, that wave is spreading out in a sort of circular pattern, and it's going to reach the screen over here, and it will have travelled a slightly different distance. And if we do the same thing for each of them, we will find that at some point they are going to cancel out. So right here you can see when it's landing, when they're both arriving, a peak and a trough are meeting, so you're going to get cancellation here. Go along a bit further, moving them both across a bit, and we get another spot where we're going to get addition. You can see the peak and the peak are matching up together, so we're going to get a bright spot here. Okay, so we go bright central maxima, dark spot, bright spot. Let's see what happens if we make the gap through which we're diffracting smaller. Okay, so I'm going to simulate that by moving these over to the green spots. That will become our new slit width. Right, we'll do the same thing again and see. So to symbolise that, I'm moving these closer. So this is our gap now. It's a narrower gap. Everything else is the same, but we've got a narrow gap. And again, as you would imagine, right at the centre, we're getting a bright spot. Now if we go out, right, you might notice that we still haven't got to cancellation just yet. And I'd say this is where we're going to get the cancellation. So here we're getting cancellation, and you have to go even further along. So hold on, there we are, nearly there, nearly there. Whoops, nearly broke my model there. Okay, so I'd say that at this point now we're hitting a bright spot again. So what's interesting here is that when you've got a narrower slit, the diffraction pattern is more spread out, which is what the equation tells us as well. But this helps us to visualize that. Hope you found this enlightening. Thanks for watching. Okay.